Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 1861. It's the rotating the box, and it's a similar kind of problem from the rotate image. It's a problem number Leetcode 48. It's a similar kind of problem. Okay. So what the question is saying that, let's try to understand first, and then I'll go with deep dive so you can understand how we can solve this type of problem. Okay. The very first thing we have given is matrix we have given, and its name is box grid. So if you look at the box grid, it contains some special character like a has, dot, like that. Okay. And there can be a star also, means a stone is called has, any obstacles we have, right, that is called star, and we have empty means we have dot. मतलब अगर आप नीचे आओ यहाँ पे आप देख सकते हो, राइट, कि जो स्टोन्स हैं इसको ऐसे डिफाइन किया गया है. इफ दिस इज नॉट स्टोन and if this is stuck kind of obstacles, so it's kind of a wall, you cannot cross this. So even if you rotate, right, if you see that these three are on the top, it is not going down, right, because that is a obstacles. Okay. So the question saying that we have given the box grid, right, it is a matrix n cross n, m cross n matrix, and it is representing a side view of box. It is a side view of box, so each cell of the box is one of the following. So either any of these can be there in the grid. So now the question saying that the box is rotating 90-degree clockwise, which is causing some of the stones fall due to gravity, and each stone fall down until it lands on the obstacle, right? So let's suppose if it is gravity, obviously if this is a kind of let's suppose a place where you put the stone, and if you rotate these vessels, let's suppose, so these sounds will go down, right, over the another stone. Just assume that a glass, right, you have put on the surface, right, or on a table, right, and it is in horizontal position, right. When you put in the vertical position, means 90-degree, all those stones or coin can go down directly over one each other, right, because that is the due to the gravity it will fall, right. So that is what it is saying. So each stone fall down until it lands on the obstacles, right. Another it is saying that it another stone and or the box of the gravity or the box of the bottom, right. Let's suppose if there is no stone is there, so it directly will go to the surface, right, with the bottom of the box. Like that it is saying. It is also saying the gravity does not affect the obstacle position and the inertia of the box rotation, because when we do the rotation, right, it depends on the inertia and the speed also. So that things it doesn't count, because it is already saying it doesn't matter on the inertia, and does not affect the stone's horizontal position. So you cannot take care of all the physics things, only you have to take care of the gravity, because gravity applies here and not the any other things, right. So it is guaranteed that each stone in the box grid rests on the obstacle and another stone and the bottom of the box. So this is a guarantee. Now it is saying that return the matrix representing after the box rotation. So which is very important to understand, because if you understand this concept, then you can return the box what is the matrix after the box rotation. So to understand this, let's go with the basics so you can understand here. Okay, so let's assume that we have a matrix like this. Okay guys, so if I'll divide this matrix like this, so we know that the I will go this side, right, for any what do you call the cell, right, that is called ij. Any cell we can represent I and j, and j will go in this side, right, we can say j. If j is 0 0 1, right, we can say I is row 1 row 0 and 1, we can say that, correct. Means for any cell of this coordinate, right, we can say for the matrix we can say cell is I and j, and if we want to represent the coordinate, we can say it is 0 0, and then it is 0 1, and then it become what is 1 0, and this is 1 comma 1, right. So these are the coordinates we have. Now think about this. Like, let's suppose if I'll go with the 90-degree rotation, right? After 90-degree rotation, what will happen, right? Means rotation, 90-degree rotation in the clockwise, we can say clockwise. So 90-degree rotation, if I'll talk about the mapping, so what will be the mapping? Means how will it map each cell after the rotation? So for our matrix, let's cross M cross N matrix we have given. So N cross N matrix we have given. If I'll say, okay, in this case M and N both are same, so we'll say N into N in this case, right? So this is our matrix we have, because 2 into 2, right? Here because we have N is 2. So we already talked about that I and J is our matrix, right? Cell. So after the rotation, it will become what? Is J comma N minus 1 comma I. So this thing will happen, the mapping will happen like this. So whoever is at I and J, it will go to J N minus 1 minus I. So this is the core formula that you should understand, guys. This is a core formula, right? So when we talk about the core formula, right, we should understand why we are saying that, because it depends on all the logic and the constant that we have given. So we will apply the constant later, but you understand the core formula. So when you write this, right, that 90-degree rotational mapping will happen clockwise. So for any matrix that we have N cross N matrix, now it is N cross because we have 2 into 2, right? So for example, like for our example, what is our example is N equal to 2, right? Because let's suppose this is 0 0 0 1 1 0 1 1, means how many is there? 4. So 2 into 2 is 4, right? It means 4 elements are there. Now think about the coordinate transformation. Okay, now think about the coordinate transformation. How will you do the coordinate transformation? It's very important, right? So think about the very first one, which is at 0 and 0, right? So 0 0 cell, it will go where, right? So we'll say, okay, it remains 0, 2 minus 1 minus 0. It means it go to 0 1, right? Means it will start from here, right? Once this rotation will happen, it will go to this position, right? Are you getting? So this is what it will happen. Similarly, for the cell, we can say 0 1, it will go to 1 1. I'll write here so you can point it out. Okay, 1 1. Okay, give me 1 second. 1 1. Then we can take is 1 1, it will go to 1 0, and for this 1 0 will go to 0 0. So like this, we will traverse all of this. Means basically when we are at 0 0, means the top left corner, right, it will go to the top right corner, right? When we talk about the bottom right corner, right, bottom right, it will goes to bottom left. From the bottom corner, it will go to the bottom left, right? This one, because this will also go rotated, right? Similarly, if we'll talk about this one, right, it is at the bottom right, right? So it will go to where? It will go to the bottom left, it will go, right? Like this it will go. Similarly, the bottom left will go to the top left, right? It will go. So these are the things that you should understand, right? So basically, let's suppose the case that we have not the 90-degree, but it wants the cyclic. So how it will move, right? So just take this screenshot so we'll understand. Okay, we'll come back here if you want. So let's suppose if we want to the if it is clockwise, let me write here itself. Okay, so if the rotation, the cyclic rotation will happen, cyclic movement happens, right, in place rotation, then what will happen? So you will move to 0 1, then 1 0, then you will go to the 1 0, right, and then you will go to the 0 0. basically after this you should go to 1 1, sorry, and then 0 1. Means basically you will go with, start with the 0 0, you will come back to the 0 0, right? Because this is a circular movement. Okay, this is exactly what happened in the in place rotation problem, right? Like if you remember the, if you any of you have solved the problem Leetcode 48, this is a image rotation, yeah, rotation image problem is there. Okay, so if you solve this problem, you will do the same concept, but you will rotate like this. So each concept we should understand. Okay, so this is just for additional notes you can apply in there, right? Because you will start from 0 0, then 1 0, 0 1, then 1 1, then 1 0, and 0 0, you will come to here, right? So this is your circular movement will happen. Okay, now let's suppose that if these things we have given, and we know that after the clockwise rotation what will happen, that this will this rotation will happen, means each cell will get transformed from one place to another place, right? So how we are going to solve this problem? So let me show you something which is very important, guys. Okay, okay, so I'll show you some code, right? So when we do the rotation, right, let me increase this height. Okay, okay, so let's suppose that we have given this matrix, right? And if we want the 90-degree rotation clockwise, so what we will do first, we'll know that we will find the mat n, right? It's a matrix length. I'm talking about n cross n matrix itself, right? Then the very first you need to do the transpose. So very first, you once you will do the transpose, then you have to do the reverse row. So when you do the transpose, and after that if you'll do the reverse, right, means basically you will say, okay, what is the, why these methods we use, like transpose and then the reverse? Because see, once you will the transpose plus the reverse, right, so this trick is a standard way to rotate 90-degree clockwise. Okay, in place rotation, in place means we will not take any extra spaces, right? So that is why we should use the transpose and the reverse one, right? If you see down, if you see, we are doing the in place one. Okay, so to understand this, let's go back to the place where we are talking. Okay, so let me clean it so we'll understand. Okay, so very first we know that we have to do what? We have to do transpose. Okay, so transpose means what? Transpose means we have a matrix, guys. Okay, and matrix I and J, we can say that, right? It means if you do the transpose, we will get the matrix J and I, right? So this is matrix J and it is I, right? So basically we what we are doing here, we swap rows with the columns, correct? There is row and this is column, so we do the column first and rows later, right? Means we swap the columns, rows with the columns, we can say. So very first, let's suppose for a matrix, if we'll take 1 2 3 4 5 6 7 8 9. Okay, so if we will take this matrix like this, okay, if we'll take this matrix after transpose, what will happen? It will become 1 4 7 1 4 7, then this will go to 5 8, right? So it will go to 2 5 8, now 3 6 9. If you can see, the rows is going to the column and it got swapped, right? If you observe, let me show you. So this is our 147, it goes to the rows, means the column goes to rows. Now another column we have is 2 5 8, it goes to the next row. Now it is going 3 6 9, it goes to the last row. Like this the transpose works. Okay, so basically if you have noticed here, okay, so if you notice here, the two moved from where 0 1 to 1 0. correct? And 7 moved from 20 to, this is called what, 02, right? 02, yes, 02, correct? The 7, it goes to where? From 7 to, it goes to here, right? So the row becomes column, basically we can say that. Okay, so when we talk about the sweep across the diagonal, right, we take I and j, and I and j goes to j and I. Basically this means if you talk about the 0011 or 22, so these are the coordinates we have given, so these are diagonal cells, we can say that, right? So it will move to the another diagonals, we can say that, right? But how will implement that, will that is the different things, right? How the Java code will work, that is different thing. Okay, so when we make the loop, right, at that time we know that we'll start I from 0 to the n, right? And inner loop, when we talk about the j, so j should start from I plus 1, one more, right? And it goes to till the end, and then you will do the swap. You know that you will take the matrix I and j on the temp, and then you will swap with the ij to ji. That's all, right? That will that we can show you later. Okay, so you will say, okay, why will use the I plus 1? Because lower triangle already swept, right? And diagonal we don't need, right? So diagonal no need, right? So otherwise you will swap twice, so we have to take from I plus 1. Okay, now come back to the reverse. Let's understand now the reverse. So you understand the transpose, you can take the notes, pause it and take it. Now let's talk about the reverse. When you reverse each row, point number 2, we can say point number 1 is reverse. Now understand reverse each row. So after transpose, what we have, guys? We have seen that 1 4 7 2 5 8 and 3 6 9. This is what we have reverse, correct? If you remember, now every row, now we have to reverse every row, right? So let's suppose, let's reverse it, right? So we'll talk about the row 1. Row 1 is what we have, 1 4 and 7. It goes to 7 4 1. Okay, similarly row 2, this is row 1, row 2. Row 2 goes to how? 2 5 8 we have, so it will go to 8 5 2, correct? Let's talk about row 3. It has 3 6 9, it goes to 9 9 6 3. And so if you'll talk about the final matrix, it will look like how? Let me show you. Okay, the very first is 7 4 1 8 5 2, and then we have 9 6 3, and this is your 90-degree clockwise. So now you understand why does this work, because you have to think geometrically, right? Basically the very first thing is transpose, right? Once you transpose, means it will convert the horizontal direction into the, if it is horizontal, it will go to the vertical, right? So understand the very first transpose, then the reverse row means we fix the orientation to the clockwise rotation. Without every reverse, matrix is just mirror the diagonal, right? So that concept is very important, right? Means without reverse, right, matrix is just mirror the diagonal, so you will do that, just a simple thing, right? So to understand these two concept is very important. Okay, so when we do the transpose, right, when we do the transpose, let's understand the coordinate understanding. So let's say we have I and j. What we are doing? We are doing j and I. So that's it called transpose. Now you do the reverse. So now you do the reverse row. It means the column is getting changes. Only column changes here, right? So how it is get changes? So I and j, basically you are doing is I comma n minus 1 minus j. This is what we are doing, guys. If we both combine this, what will happen is we'll say I j, it goes to the transform j I, and then it transform to j, and then n minus 1 minus I. So this is what we are talking about, which becomes very simple, right? Means j n minus 1 I, right? This becomes very important. So you understand how this works, and I'll also shown you the code how to transpose and reverse it, right? Because it's very important to understand that part. Let me show you again. So when we talk about the transpose, right, we, if you see here, we start from I00, it goes to I, it goes to j I plus 1, right? It start from the j start from I plus 1, right? Why we start from I plus 1? Because the lower triangle already has been swept, right? And the diagonal we don't, no need. So you will swap twice. So to avoid the swapping twice, you have to start j from I plus 1, and this is just a swap thing, right? Similarly, we have understand the reverse, right? And to reverse this, if you see here, we are just doing the in place reversing, right, of each one, right? So this is what we have. Means the very first thing is that you do the clockwise rotations, right? So you have to do the transpose, and then you have to do the reverse of the things. Now come back to our code. Very important. Sorry, I have taken much time, but it's really worth to understand the concept, and then we go for the code, because the code will become very easy. Okay, let's talk about the rotation. We have given this box, right? And in this box, if you see here, right, let me increase the size. So if you see, we found the m, because this is not n cross n matrix, this is m cross n matrix, so we have to take m and n, both we have given. Now you just need to do is what you have to create a result, right? And you will store the value there, right? Because we have to return it. Okay, if you see here, okay, that is why we have to take the result. Now the very first thing is you have to create the transpose of each input we have given, and you will store on the result itself. Okay, do not change the value, okay, on the of the grid. So you have to take the result. Now once you done that, you will do the reverse. So you have to reverse each row in the transport grid to complete the 90-degree rotation that we have already seen, because the reverse will not do the same reverse thing twice, but it will mirror the diagonal, right? So we'll use this part, correct, guys? Now you have to apply the given constant that we have given in the problem. So till now, that is a simple 90-degree rotations rules, you can say, concept, you can say, or you can say the basics, you can say, that we have understood. Now we are coming back to the question. Okay, the question is this, that we have given, right? So you have to read the question, what the question is saying. So very first we have to apply uh, gravity to let the stone fall to the lowest possible empty cell in the column. So to fall on that, if there is a obstacle, it will stay at the obstacle. If there is if this is a stone, it will stay at the stone. If both are not there, it will go direct to the base of the vessels, or you can say, or the grid, you can say. So for example, if j is 0, we'll start from j to m, because m cross n we have, then we'll start with the reverse n. We basically we process each cell in the j from bottom to top. So we'll start from the bottom to top, n minus 1 to I, right? Like that we will process. Then we'll check, okay, if result contains dot, means we found empty cells, right? It means the stone can fall directly into the base, right? So we'll take the next row with the stone is minus 1. Then we'll look for the stone directly, if it is empty cell or not. If it is empty cell, right, then we'll check with the k, I minus 1, k is greater than 0, k minus minus. So you will take the things. Let's suppose if it is star, means this obstacle, like a wall, it is not it cannot cross, the stone cannot cross the that position, right? So it will stay over there, means we have to break that. If it is has, means we found the stone, no obstacle in that, means we have to go with the next row with the stone, means we have to say that next row with the stone is not -1 but it is now k, and then you will break it. Similarly, if stone was found above, right, it fall into the empty cell, right? So if you check if not -1 and if it is empty, right, you will say okay, result ij equal to this, means a stone will come to that exact uh, what you call inj. Okay, and finally we'll return the result. I hope you like this video, guys, and if you have any suggestion, please ping me in the comment box. This is just a reverse functions, right? If you are struggling with the DSA preparation, you can join my online classes. Already classes are going on, so you can join the classes. Thank you so much. I'll see you in the next one, and that's all I have in this video. Thank you so much for joining, and please like, subscribe, and share with your friends if you are there also preparing. Thank you so much. Bye bye. See you tomorrow.